I'm Austin, and I'm a chemical engineer.
I'm Tracy, and I'm also a chemical engineer.
I'm Josh, I'm a civil engineer.
And I'm John Guthrie, here to interview these E101 students about their hovercraft. So, what design problems did your group face, and how did y'all address these problems?
Well, our first problem was trying to get the hovercraft remote controlled. So we had to go to a hobby store called Roddick Hobby. And we talked to an expert, hobby expert, to help us program it to make us go forward and backwards, speed control. And that really helped us. And the second problem was the weight, our weight. Because our first design was too heavy on the back and wouldn't really move on carpet. So we had to go back and redesign it, cut that in half to make the weight more distributed. Then our third problem was the airflow underneath. Our first design was the holes were just everywhere, so the flow was not level. The holes were just everywhere, so the flow was not level. So our second design, we put a hanger up the middle and put a whole symmetrical around it, so it had even airflow.
All right. So, how did your project perform at the actual freshman day design project?
Well, we were pretty satisfied with the results. We placed 6th, and the main thing we were proud of was that when we got up there, we put it on the starting line, and it performed as we expected. We didn't have to make any modifications. We didn't have to change anything. Other groups are struggling with that, and that's one thing we were proud of. And we have a video clip of our trial run at the engineering.
What would you do differently if you had to do it over?
Well, our time management was not well. So the first part planning, we went well. We researched the building process. We didn't plan our time well. We were procrastinating. We thought it was going to take a little bit longer than it did. But when we actually built it, it didn't take that long. So we kind of didn't have enough time at the end to fix all of our errors. So.
All right. Well, what advice would you give to next year's freshmen?
Let me see. First of all, I have to say to get started earlier. I know everybody says this every year, but it's true. We were told this and we didn't do it either. So get started earlier. Secondly, research your actual project. It's good to know what exactly you have to do instead of winging it the week before. And let me see. Thirdly,
you need to communicate with your group better. We struggled with that, but we made a Facebook group, and we all had the information. It was easy to access. And communication's a big part. You need to listen to your group. You don't just need to have one idea and stick with it. You need to let other people participate, and they could give a good idea that you might not think is good, but it actually works better. So communication's a big key factor.
All right. So how did you use the design cycle and the planning and building of the hovercraft?
I'm Alan Shaw. I'm a computer science major, and I was part of the Flyin and the Hovercraft project. So in this project, we had to define the problem. And the problem was that we had to make a hovercraft that was able to hover on carpet and maneuver around a course. So in the research for this project, we decided to watch YouTube videos and search online about common hovercraft ideas. So we figured out that a rectangular shape was a perfect idea for this project. So in making this project, we had to use a styrofoam board, plastic sheeting, an air mattress pump, and a steering system from a remote control boat. So when we built this and tested it on freshman engineering practice day, we figured that it wasn't working well on the carpet. So we decided to cut the board in half just to manipulate the weight to make sure that it was even. And then we decided to pin the bottom of the plastic sheeting and put hose in symmetrical areas so it would be able to hover better. And we figured this decided this style and design was working better, so we took this to freshman engineering day and tested it, and here's a video of our final product.